Hello everyone, welcome back. We often hear that people love to say IHSG is driven by global risk or USDIDR follows the dollar. But most of the time, that's just correlation plus storytelling. In this video, I build a directed macro network that answers a sharper question. Which variable adds real forecasting value for another, out of sample, and with what lag? We'll compare three layers: co-movement, lead lag, and Granger-style predictability, both linear and machine learning. First, the boring part that decides whether your results are real, the data setup. I'm using IHSG USDIDR, IDR 10-year bond, US 10-year bond, VIX, DXY, and Brent. Key point: these are different asset types, so they cannot be compared in raw levels. So I transform them into a consistent change representation, align calendars, and handle missing days. Also very important, timing. US variables update after Indonesia market hours. So when you see VIX leads IHSG, part of it can be genuine information flow, and part can be the clock. In this project, I treat that as part of reality, but I interpret it carefully later. This slide is only for intuition. Everything starts at 100, so you can see co-movement and regimes. Two big visual truths. One, VIX is the stress amplifier. It explodes in crisis periods. Two, IHSG and USDIDR can trend for years, so pure level charts can fool you into thinking there's predictability. This is why we separate. Moves together from predicts each other. Now we go one step more quant. Lead-lag correlation. This is not causality, it's a timing check. Here, the strong negative relationship around the center basically says, when equities sell off, the currency tends to weaken. But here's the trap. This could be same shock, same day. Lead-lag correlation cannot tell you if USDIDR adds incremental forecasting power once you already know IHSG's own recent behavior and other global variables. So we use this slide as a hint, not a trading signal. Same method, but now DXY versus IHSG. Typically, stronger dollar equals tighter global financial conditions, and EM risk assets feel it. If you see correlation stronger when DXY is shifted earlier, that's consistent with US pricing moving first. But again, correlation is unconditional. DXY might just be a proxy for broader risk, or correlated with VIX. So next, we move into conditional predictability tests. IX versus IHSG is the classic risk-off channel. If VIX moves first, Asian equities may react with a delay. But I want to stress something. Lead-lag correlation is still not answering the real question. The real question is, does VIX help forecast IHSG beyond what IHSG already tells you about itself? That's exactly what Granger-style testing is designed to measure. Now, we enter Granger territory, but I'll say it in plain quant English. For each pair, I compare two forecasting setups. Baseline, predict the target using its own history. Enhanced, add lagged history of another variable. If adding that extra variable consistently improves the fit, the relationship is flagged as Granger significant. This heat map is the significance map. Brighter means stronger statistical evidence that the extra variable contains predictive information. Two warnings. With many variables and many lags, you get multiple testing. False positives happen. This is linear. If the true relationship is regime-based or threshold-based, linear Granger can miss it. Here I turn the heat map into a directed network. Arrow direction means past X helps forecast Y in a linear sense. Edge strength means how strong the statistical evidence is. This is powerful for storytelling, but I treat it as a diagnostic tool, not a final truth. Because statistical significance can be large, even when the economic impact is tiny. So the next step is the most important: out-of-sample predictability gain. Now we stop caring about p-values and focus on performance. For each pair, I measure, when I add lagged X into the model for Y, how much does prediction improve on a test period? This converts the question from, is it statistically detectable, to, is it useful and does it generalize? If a cell is near zero, it's not useful. If it's negative, adding that variable makes you worse. Classic overfit or unstable relationship. If it's positive and meaningful, now we're talking about a feature worth using. Same idea, now shown as a directed graph. Arrow means adding X improves prediction of Y out of sample. Thicker or brighter means larger improvement. This is the version of the network I care about for building forecasting engines because it's tied to generalization, not just in-sample detection. But we still have a limitation. Linear models can't express conditional logic well. Markets often behave like this relationship matters only in stress or only above a threshold. So next we switch to machine learning. Same experiment, but now the forecaster is random forest. This model can capture nonlinear effects like thresholds and interactions. So if you see a relationship that is weak in the linear map, but strong here, it suggests the predictive link is nonlinear or regime dependent. This is why I like this step. It tells me not only what predicts what, but also whether the link is likely linear or conditional. And here's the final product, the ML Granger network. It's a directed graph of incremental out-of-sample predictability in a nonlinear model class. How I read it as a quant? Identify the main drivers, nodes with strong outgoing edges. They are candidates for global factors, risk stress, dollar conditions, macro shocks. Identify the main receivers, targets that become more predictable when you add global information. Often those are local risk assets like IHSG and USDIDR. Translate edges into features and rules. Not buy because arrow exists, but use the strongest edges as feature candidates. Then validate stability in rolling windows and evaluate trading performance under transaction costs. One more honesty line. This is still predictive causality, not true structural causality. But for trading and risk systems, predictive causality is exactly what we want. First, yes, there is real predictability in the data, but it's not huge and it's not stable every day. In daily FX, most macro signals are weak in normal times and stronger only in specific environments. Second, the most consistent information is not a single variable. It's the global risk regime, risk on versus risk off. That's why stress proxies like volatility, dollar strength, and global rates keep appearing as useful drivers. Third, when the random forest results look stronger than linear, it doesn't mean the market became easy. It usually means the relationship is not a straight line. It's more like when stress crosses a threshold, then behavior changes. That's exactly what nonlinear models capture: trigger zones and interactions. So the real output of this research is not a magic predictor. The real output is a disciplined way to filter macro variables and to operate differently across regimes. Thanks for watching, and see you soon.